Bienvenidos, Ushamdi, and welcome Anne Arundel Community College learners from the Spring 2023 semester taking the CTS-233 Section 400 Network Programmability course. This is the Cisco Networking Academy's DEVASC 200-901 Certification Exam Preparation course, and in this video tutorial we're going to be taking a deep dive into Lab 8.3.5 where we're going to be exploring the Yang models. Now, we're going to be looking at basically two different types of Yang models. The first is going to be the open model, and as the name would indicate, an open model means that it's sort of vendor agnostic. In other words, it would be something that the IETF would create, and we're going to actually see their name inside of some Yang models. And then you've got the native models, and the native models, again, as the name might lead you to believe, those would be vendor specific. Now, the RFC is a great analogy here. So the IETF ratifies RFCs, right? So RFC 2328 is the OSPF for IPv4 RFC. So the IETF comes up with a sort of generic standard that is applicable across all the different vendors, right? And with the Yang open models, it's the same thing. They're coming up with these data models that are agnostic to the vendors. In other words, they're sort of generic models that would apply to all of the vendors. And then what happens? Just like OSPF and just like the Yang models, the vendors, specifically Cisco, which is what we're interested in here, will take a look at the model and say, you know, hey, that's a great idea, and now we're going to customize it. I'm going to take that Yang data model, and I'm going to do something for the NXOS, and I'm going to do something for the iOS XR and iOS XE. And so those are the native models. Just like Cisco did when they took the RFC for OSPF and they decided to come up with some stub types that were Cisco-only stub types, right? Okay, so that's what a good analogy would be for understanding these two different types of Yang models. So then the next question is, well, what exactly is Yang anyway? Well, Yang stands for yet another next generation, and it's funny, you would think the name might be something like yet another acronym in the computing world and networking world, but it is yet another next generation. And Yang is a data model, and it's this Yang data model that really is the foundation for model-driven programmability. And then you might ask yourself, well, why do we need model-driven programmability? Well, think about how we've been doing things over the last couple of decades, right? It's either through some SDK customized for that device and that operating system version, or a CLI script of some kind, again, customized for some specific vendor's devices. Well, the idea behind Yang is, and especially on the open Yang data model side, is that we have some sort of vendor agnostic universal description, blueprint, if you will, that describes that device, right? That models that device or that type of device, right? Like switches or routers or wireless access points or whatever the case may be, right? And so, again, you've got the open model, which is doing that in sort of a vendor agnostic way. And then you've got the native models, which is where the vendors are getting in there and they're really customizing things. And we're going to take a look at what those models look like here in just a second. So, Yang basically describes four types of nodes, right? And that's inside the Yang file. You're going to see that there's four different types of nodes. And it's pretty straightforward. You've got a container. And a container just basically groups together lists, right? List nodes. And then you've got leaf nodes, which are kind of the end of the line. The leaf nodes are kind of where you're going to get your values. And then you have leafed list nodes. And we're not going to see leaf list nodes at all. So, but again, containers, lists, leaf, and leaf list. And that's what we're working with. So back to the lab, right? So that's a good, hopefully that really drives home what Yang is all about. And it's trying to sort of standardize the representation, the blueprints for these different networking devices. So let's dive in here. And again, you don't need to be on the DevASC virtual machine to do this lab. So in a browser, you just go to github.com and then /Yang models /Yang. And here's where you'll see you've got your vendor, your native Yang models. And so if I click on vendor, who do we have in here? Well, you can see they've got some Fujitsu, Huawei, but we're interested in Cisco. So if I click on Cisco, here it is. Cisco looked at the general open Yang model and said, well, we're going to do one for NXOS and iOS XE and iOS XR. Okay, well, let's dive into the iOS XE, which is where the lab is taking us. Now, the lab is telling us they want us to look at 1693. And again, if you just scroll down here, here's 1693. Now, we're using Gibraltar, the 1612 code, so you could look up here. But again, we'll just take a look at 1693 because at the end of the day, they all look pretty close to each other. Now, you've got the ISR 4K, right? Your 4221, your 4331s, and not many Yang models for those here, right? But if we were to take a step back to the 1693, you could see for this version of iOS, the 16.9.3, here are all of the Cisco-specific Yang models, right? Now, you might be wondering, hey, I didn't see anything for the IETF stuff. Where was all that? Well, that's what they're asking us to do here. So when you look at this, I mean, there's all kinds of models that describe things. And so another analogy to help you figure out and understand what Yang data modeling is, think of a blueprint, right? So blueprints are used to describe what? The buildings. And we'll use the blueprint in the sense of like you're going to build a house, right? And that blueprint is going to define the standards used to build that house. Like the foundation needs to be, you know, this deep. The windows need to be this size. The doors need to be this size. The bedrooms, the ceilings need to be this tall, right? So Yang is kind of like a blueprint. And you can see they've got it for BGP, right? And again, these are all of the native data models here that begin with Cisco. So let's scroll down, and you're going to have to go way down here. There we go. We're getting lowercase here finally. And then we're looking for IETF interfaces.yang. And there it is, right? So here is the IETF interfaces.yang. This would be considered an open Yang data model because when I click in here, this is what the Yang data model looks like. You can see here, we've got the module name, the namespace to which it belongs. And then you've got a ton of different definitions and structures that are going to define, right, what that blueprint looks like for interfaces on a device. And so you can see here, here's one for name, right, a description. So interfaces have descriptions. And so we've got a definition for that. And again, this is just a generic definition. All interfaces are going to have descriptions. And here's how that would be modeled. So what they want us to do now is they want us to copy this here. And so the way that you do that, right, you can just come over here to raw, and then that's going to transition to here, and you could kind of do like a Control-A, Control-C. So I've already copied this file out. So let's now jump onto the command line, because now we're going to take a look at pyang, right? Or pyang, if you will. Pyang. I like calling it pyang. So we're going to take a look at pyang here, and we're going to see what it allows you to do. And so there you go. I was doing some testing to make sure everything worked in my virtual environment here. So it wanted us to do a make dir, and then it wanted us to grab some models. So let's do that. So I'm going to say mkdir, and we're going to call the directory pyang. I'm going to go ahead and cd into that directory, and let's do the following command, right? So they want us to do an HTTPS, or I'm sorry, wget. So wget HTTPS, and we're going to do raw.github user content, and I'll give you the URL here, but again, I've already pulled this down, github-usercontent.com/yang models /yang/master/vendor Cisco XE 1693 IETF-interfaces. So that file that we just looked at, .yang, that file that we just looked at, we are now pulling that down. So when I say ls, you can see that there it is. Let's make sure that it's there. Yeah, so that's the same file that we just looked at. So now what the lab is asking us to do is to explore this Yang data model, this blueprint, and we're going to do it in a sort of tree structure that you kind of were able to see earlier. So pyang is a great utility. You can see I've got version 253 installed. If you needed to install it, it would just be pip3 install pyang, and you could say upgrade to make sure you've got the latest. And again, it's already there. It was just I installed it a couple days ago, so nothing's changed. So we're in that directory. So let's see what we can do with pyang, right? How can this help me investigate these Yang data models? Well, okay, I can do a -v for version. You can see the -h for help, which is what we're doing. But we're really interested in the format down here, right? Now, this is super, super cool. So we can convert that Yang data model into different formats. We can put it into a tree format, which is what you kind of saw there when I flipped up the screen. We can put it into a JSON tree, which is the JTOX format. You could do sample XML skeleton, which I think we've seen enough XML for the course. So let's go ahead and let's run this and see what happens. So if I say pyang or pyang, we're going to say -f. And again, -f is for the format. What do we want the format to be? And we want it to be a tree. So I'm going to say IETF interfaces.yang, and here it is. Now, the lab kind of glosses over some of the different components that we're going to run into. So let's talk about some of the things that we see here, and specifically, you can see the module name is IETF interfaces, and we'll just focus on what's going on up here for right now. So you've got the module name, right, which is the IETF interfaces. So this is a container, right? And so just as you would think, okay, the container's name is interfaces. Well, what does it contain? Yeah, it contains, oops, sorry, I don't want to do that. It contains a list of all of the different attributes for an interface, right? And so what do we have? You've got the module name, you've got the container, we've got the list, and then this actually starts, the read-only interfaces state actually starts a new container. So you can see the containers are out here in like a hierarchical structure. Here's the list, right? And then here are the leafs with the values that we have, right? So container, and what does a container hold? Well, one or more lists. And what do the lists have? The lists refer to the leaves, which are the values, the end of the tree, if you so to speak, right? And so that's all that's going on here. So let's break this down a little bit more. Now that we know that that's the container is going to have the list, and the list is going to have the leaves with the different values. So what's going on here? Why the asterisk after interface? And then we got a question mark over here. The asterisk means that's mandatory, right? That's the meaning of that, is that is a mandatory element here in our data model. And then we've got the question mark. Well, obviously, if that's mandatory, this would be optional, because maybe the interface doesn't have a description. Maybe the interface doesn't have an enabled status, right? But we've got a type of interface, and we've got the name of the interface. And so what are those values? Well, here, and this is one of the things with Yang, it is a strongly typed data modeling language. Unlike Python, where it's duck typing, remember we called it duck typing, where you could say, oh, if it looks like a duck and it walks like a duck and it quacks like a duck, well, then it's a duck. And that's how Python does its data typing. It just kind of looks at what you're typing in there and says, well, if it's in double quotes, then, you know, it looks like a string. I'm going to treat it like a string. And if I've got an integer there that doesn't have quotes around it, well, then it must be an integer. Here, it's different. Here, it's more like the C programming language or Java, where you're saying, okay, the variable is going to be some name, and it has to be a string. And so this is strong data typing, right? Where it is 100% certain what is going on here in terms of what these data types are. And so that's all a Yang data model is. And this is really the foundation for model-driven programmability. And the reason is to get away from all of this sort of pigeonholed, one-off, vendor-specific, you know, CLI or SDK type stuff. And that's what Yang gives us, right? It gives us the foundation to manage devices. And so how can we manage them? Well, what you're going to see in the next two labs, 836 and 837, is we can leverage these Yang data models and the blueprints that they give us, and we can use netconf and restconf. Now, if I take a quick segue over here back to the browser, in the text, it mentions this RFC 7519 being a Yang data model RFC. It is not. Yang is not even mentioned in here. I think that might be a typo. So they mentioned 7519, but that refers to JSON Web Tokens. The RFC that I would recommend that you take a look at, and again, you don't need to read the whole thing, but if you really want to dive into Yang, is RFC 6020. And you can see the title is Yang, a data modeling language for network configuration protocol. Now, remember, I just said you can use RESTconf, and you can. Now, the RFC just simply says data model for netconf, but RESTconf is going to sort of simulate and map its HTTP methods or verbs like get, put, post, patch, delete. It's going to map those to the netconf, like get or get config or edit config. And that's how RESTconf is able to leverage and use Yang. So here we look at some of the, the table of contents here. And if you were to go down to the introduction, you can see it's going to tell you about Yang, so forth and so on. I don't think you're going to see a mention in here of RFC 7519. Let me check. Yeah, no, there is no mention of RFC 7519 because I think that has to be a typo. All right. So again, this is going to go through. It's going to show you all kinds of information about Yang and its use with netconf. And you can see when we look at netconf, you're going to see that you're making RPC calls, and that's what netconf is doing in order to send its netconf commands, if you will, via the NC client, or if you're cutting and pasting. I wanted to show you how we could convert things. So if I say pyang-h and then we go to more, you can see that we've got F for the format, which is right there, but then O is for the output file. So if I was to pull back this right here, could we say something like, -O, and then we'll just say sumefile.txt, right? And now if I was to say more on sumefile.txt, there it is, right? I've got a copy of the tree for the generic interfaces, right? For the IETF dash interfaces Yang file. So now what we could do is, if we were to try to output that in a different format, not a tree format, but what if I wanted it in JSON format? So let's say JTOX, and you could think of it like a detox for JSON. And so then we're going to say sumefile.txt, and there is that Yang data model in JSON format, and you could just dump it out right there. Now, also I have, it's a simple enough to, oops, sorry. Oh, did not want to do that. Holy Toledo. All right. So I think we have, what is it? So it's called Yang to JSON. So yeah. So here's a little Python script that would basically take a file name here. And again, this is just hard coded in here. You could configure this to prompt the user, give me the name of the Yang data model file that you want to convert, but it's going to give it a unique date and timestamp. So if I was to go ahead and run this and say Python 3, we're going to say Yang to JSON.py, and you can see that it just created the output file for me. So if I say more and we take a look at that file, Control-C, Control-V. So again, we end up with that same JSON output. So you could even do something like this, which might be a little bit easier to do. Is where were we at here? Yeah, when we do this output to the file, right, it's kind of doing the same thing. So if I was to cat sumefile.txt, there it is. We've got all the JSON data there. All right, so again, sort of a whirlwind tour here of Yang, the foundation for model-driven programmability, which are these either open or native data models that describe how these devices function and work. And again, Yang is yet another next generation, and the key components that we looked at, the container, the list, and the leaf. And you know that the asterisk means it's a mandatory component, and the question mark means that it is optional. All right, well, that is going to do it for Lab 8.3.5, where we explored Yang models. Hopefully, this is going to set us up nicely for when we transition over to the next lab, which is netconf and configuring and working with the iOS XE device, and then restconf. As always, thank you guys so much for watching, and I hope to see you in the next video.